Hello, I'm Bill Wong, and welcome to Kid Close Up. We're going to do something a little bit different this time. We're actually going to compare two computer systems. One, which I put together almost a decade ago, based on a Supermicro motherboard and an Intel Core i7. The other is the latest ASUS NUC Pro 16, which has a 16-core Ultra X7. It's going to be kind of interesting, so let's take a closer look at these things. Okay, you can see this is a really compact system. And as you flip it up to take a look at the front, you can see, the power button along with the USB Type-C and a pair of USB Type-A interfaces. On the side, you can see this has got fans, and it's actually got two of them, one on the top and one on the bottom. There's the key lock for security. We'll take a closer look at that a little bit later. On the back, power is where it goes in, then two HDMI ports, a pair of Type-C Thunderbolt ports, and then a pair of Type-A ports, along with 2.5 gigahertz Ethernet connections. And again, an area for the fan. Opening the system up is actually pretty easy. You just flip this little lid here, open it up, and you can see now you have access to the M.2 slots. Now we'll take a little closer look here. That one is for the wireless support. You can see on top of that is going to be another longer M.2 card. It hasn't been installed yet. And the default M.2 card with the SSD. It's got the one fan on this side along with the heat sink. And you can see that it just folds up like so. Again, taking a closer look at the key lock. You can see how it would latch in there. Once it's installed, you would not be able to open this thing up. So let's take a closer look at what we're replacing. The mini tower system on the bottom, it had an Intel Core i7 67K. At the time, was one of the top of the line systems, but it only had 4 cores. It actually would run 8 threads. Added to it was an AMD Radeon Nano, so that's an additional PCI Express card, and it had one M.2 slot. The nice thing about the tower, obviously, is we could put a lot of hard disk drives in there, which I did as well. Compare this to the NUC 16 Pro. It's obviously significantly smaller, but it's actually a higher performance system. It has 16 cores. It has the same amount of memory. It turns out that the ASUS NUC is soldered in, so you can't upgrade that. But 64 gigabytes is not too bad. It has a built-in GPU and also a built-in NPU. We'll get to that a little bit later, but the NPU is going to make things more interesting in the future. There are actually a pair of M.2 slots because, it used to be putting small hard drives into the NUCs were what was done. Now it's almost always M.2 cards, and having 2 of them there is very handy. In addition, wireless support includes Wi-Fi 7 and Bluetooth 6, and Ethernet is actually 2 ports of 2.5 gigahertz. I used to be the director of PC Labs at PC Magazine, and benchmarks is one of the things I always took a look at. Likewise, I always tried to make sure that everybody took it with a grain of salt. And here we have a comparison of the performance of the processors as well as the GPUs. And you can see that the older Intel Core i7 6700K is a bit slower on the single core and a lot slower on the multi-core. Now, obviously that's part of the additional cores because there's 16 of them, but there's a difference in the number of cores that are in the NUC. There are actually 3 different kinds of cores. A couple of them being very high performance cores, which normally is what you're running on. Some medium performance cores, and then some very low power cores. So if you're actually going to be running this system and it's going to be idling for the most part, those things really keep things down in terms of power consumption. The video side, this is where things get a little bit more interesting because obviously the Intel Arc B390i GPU is built into the processor, so it doesn't have the capabilities that a standalone card like the Radeon has. Still, it's a major improvement over 10 years ago, and if you actually went to a higher performance system, you could actually get something that's significantly more powerful. To start with, I was testing the system with an ASUS Zen screen, and it is nice because it actually plugs into the Thunderbolt port and can be powered directly by it. Now, this is really more of a portable screen, and you can tie it into laptops as well, but it's actually kind of nice if you're going to just sort of grab the NUC, take it with you, and want to plug it into something. My actual system, and where it winds up finally, has multiple monitors and takes advantage of all of the display ports on the NUC. In particular, the main screen here is a 4K screen plugged into the HDMI, and a pair of screens on either side that are plugged into the display port. Had to pick up some extra cables for the USB Type-C connection, but they work just fine. I also have another tablet that I plug into the HDMI that I can do drawings on, things like that. So I take advantage of all 4 ports that the system can drive directly. The tower system I had was a bit noisy if you use the standard heatsink. Instead, I wound up using a liquid-cooled system, and you can see here that the radiator actually is on the top with multiple fans that run at low speed. There are additional fans that also keep the system cool, and on par, the ASUS NUC is very quiet. If you actually accelerate it to its higher performance end, it winds up being somewhat noisy, but not that bad. I actually have a pair of Altec Lansing speakers that I wanted to use. The problem is that they're the old style. They use jacks like the one that's at the bottom, which is actually a USB adapter. Alternatively, you could use the Bluetooth support that's built in and use something like the Bose speaker, which I happen to have as well. But for most people, they'll probably wind up using an HDMI display or something like that that has speakers built into it. Well, that's it for this first round. We're going to take a closer look at the NUC's NPU, and we're also going to be taking a look at how we can take advantage of the second M.2 slot to put in an AI accelerator, so you can get different levels of AI performance out of a very small, compact system.